Welcome to another coding math video. Today we're going to talk about linear interpolation. Linear interpolation is a method for finding an unknown point between two known points on a straight line. Let's say you're heading to the beach that is 100 miles from your house. Along the way, you decide to stop at a restaurant, and this restaurant is a third of the way between your house and the beach. Assuming that everything is on a straight line, the house, the restaurant, and the beach, you may have guessed that the restaurant is at mile 33, and the math is easy. Basically, you just multiply a third, or 0.33, to the range, which is 100 minus 0, and so you get mile 33. To interpolate is to insert into something. A linear interpolation is to insert a point on a straight line between two known points, and these two known points in this case is the house, which is at mile 0, and the beach, which is at mile 100. And the amount of interpolation is 0.33, and so we get mile 33. But this is the case where one of the points is 0. So let's say that you had lunch, you are still hungry, and so you're heading to a boba shop. And the GPS says that the boba shop is at 0.2 or 20% from the restaurant. So now the range is between 100 and 33, and you get 67. And the amount of interpolation is 0.2. So basically, if you use the same equation, you would just do 0.2 times 100 minus 33, but it's just the distance between the restaurant and the boba shop. So what you need to do is that you need to add 33 to the value that you calculated, and then you would get 46.4. And with all that whole story, all I'm trying to say is that the equation is y equals to min plus the range, which is max minus min, times the amount of interpolation. Now let's look at it differently. You know three known points. You know where the house is, you know where the boba shop is, and you know where the beach is. But now you don't know where the boba shop is relative to the house and the beach. We want to figure out what is the amount of interpolation. And it is as easy as doing boba shop minus house divided by beach minus house to get the amount of interpolation. And with that, you get 46.4% or 0.46. So now that we have all the math out of the way, let's figure out how to use linear interpolation in P5.js. Luckily, there's a built-in function called Lerp, and it takes in a total of 3 arguments: the first point, the second point, and the amount of interpolation. Let's start by declaring 2 points. Point 1 is going to be, how about, let's give it at 0. I'm going to just give it the x coordinate, and then point 2 is going to be at 300, and then I'm going to declare the y coordinate to be 200, so it's between 0 and height. Alright, so now we can draw these 2 points using an ellipse function, which takes in a total of 4 arguments: the x and y coordinate of the center of the circle, and then the width and height. So let's do point 1 comma y, and then let's do, how about 50 for the width and the height, and then I'm gonna color it red. Alright, so we have the first point, and then we're going to do the same thing, but this one is going to be the second point. Alright, I'm going to actually color it white. I want to move the origin point from here a little bit out by 50 pixels on the x direction. So let's do translate by 50,0. Perfect. And then I'm also going to write the amount on top of our circles here. So 0.1, and then y value, let's do minus 40. Let's try that for both. Perfect. So we have 0 and 300. And then now I'm going to use the Lerp function. So the Lerp function, let's declare our third point. Takes in a total of 3 arguments, right? So we're going to do linear interpolation between 0.1 and 0.2. So we put 0.1 here and 0.2 here. And then how much is the amount of interpolation that we want to do? What if we start at 50? We can draw it out, right? So let's do 0.3 here, 0.3 here, and 0.3 here. And then how about we color it blue? It is at 150. So the equation is minimum, which is 0, plus 300 minus 0, which is the range, right? Which is 300 times 0.5, which is 150, and that's why we get this distance here. And now, what if this point here, point 1, is now at 100? And now point 3 is at 200, because now 50% between the range of 200 is 100, and then add the minimum of 100, and then we get 200. Now I want to show you another powerful usage of the Lerp function, which is to do an easing motion from one point to another. Let's again declare 2 more points, but these 2 points are going to be vector objects because now I want them to hold 2 values, x and y coordinate of the points. So let's first declare point 1 and point 2. Then point 1 is going to be, we can use a function called createVector to initialize the vector values. So I want it to be in the middle of my screen. So width divided by 2 and height divided by 2. And then point 2, let's start it at, how about just 0, 0. What if we just draw both of them? So we're gonna extract the x value for the first argument, pt1.y, and then let's do the same size of 50. I'm gonna copy and paste this for point 2, and then I'm going to change the colors. So the first one, let's do white, and then the second one, how about yellow? Now what I want to do is that I want to use linear interpolation or the Lerp function to slowly ease the location of this yellow circle to where the middle circle is. And I'm going to do that by basically interpolating the distance between the location of point 2 and point 1 by a certain amount of interpolation. For example, if we do 20%, basically we're just moving 20% closer between the distance of the white circle and the yellow circle. It will get closer and closer and closer every time. So we can do that by just using the Lerp function. So point 2 of x will be equals to Lerp of point 2 of x, right? And point 1 of x, and then we want to, how about we just change it by 20% for x, and we do the same thing for y. Did you see that easing motion? And you can just change this interpolated values, the amount, based on how fast or how slow you want that movement to be. And another cool trick is that what if instead of giving it a constant value here, we can just do 0.1 of x to be equals to my mouse x location, and 0.1 of y to be equals to mouse y location. And then now the yellow circle is following my mouse at a cool easing motion. So I'm going to change this back to 200, 200, and then 0.2 here, y to be 200, and then this to be 0. And I'm going to print the value of 0.2 of x as you can see here, it never actually reached 200, right? Because it's always trying to interpolate the point between the 2 points and get 20% or whatever is the interpolation amount that you put closer and closer and closer to the final point. So what you can actually do is that you can change to a fixed speed when you get closer to your target. But in my case, it's fine, so I'm gonna leave it as is. If you want to see another example, a more complicated one of how to use linear interpolation, I have another tutorial on marching squares where I use linear interpolation to find a smoother approximation of the contours. So this is just a quick touch on what is linear interpolation. If you want me to dig deeper into this topic, be sure to let me know what you would like to know. Bye!